Yesterday we started probability. We learned about independent events and dependent events. Can someone tell me the difference between independent and dependent? Jordan?
Independent, they don't belong to each other.
Yeah. On dependent, if you have the outcome of what you do first affects the outcome of what you're going to do second, correct? But independent, the outcome of event A doesn't affect the outcome of event B. They're two independent events. Today we're going to look at mutually exclusive and not mutually exclusive. Here is our first slide. On your notes handout you have a line on the top that says mutually exclusive. Next to it, if you would please write the formula for mutually exclusive down. If two events, A and B, are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. A key word that I would look for here is or. You might circle that, highlight it, underline it. The word or kind of gives me a hint that it's mutually exclusive. Yesterday, what did we look for that told us maybe it was either independent or dependent? And usually told us that. So today, a common situation may be, let's say you've got a deck of cards. You want to, what's the probability of selecting an ace or a six? You're only drawing one card out of the deck, but you're considering two different numbers, an ace or a six. And that word or will kind of be a hint to you that it's going to be mutually exclusive. Now, we are going to talk a lot about cards today, so I do need to make sure you guys are all familiar. How many of you have played cards before? Are we somewhat familiar? If not, it's not a big deal. We'll talk about it. In a standard deck of cards, do you know how many cards there are?
52.
52. You ever play 52 pickup?
Yes.
You don't want to. In a standard deck, there are 52 total cards. Of those 52 cards, or in those 52 cards, they are divided into 4 categories. What are those 4 categories?
Cards, spades, clubs, and diamonds.
Hearts, diamonds, spades, and clubs. I would almost draw a picture underneath so that you know what we're talking about. Heart, obviously it's a heart. Diamond is a diamond. What's a spade look like?
Like a pedal.
A shovel. I always call them shovels over there. Shovel. It kind of looks like a shovel, like an upside down heart almost. Something like that. Very hard to see. And then a club. What does a club look like? That is the clover. Now, in a set of cards, a deck of cards, there are some red and some black, right? Which ones are red? Hearts and diamonds. Those are red. And spades and clubs are black suits. So we have 52 cards. Those 52 cards are divided into 4 suits. Hearts, diamonds, spades, and clubs. How many hearts are there in a deck of cards? 13. There are 13 hearts. There are how many diamonds? 13. How many spades?
13.
And clubs? 13. And when we talk about a standard deck, we're not worried about jokers. They're not included. So in a deck of cards, let's talk about what kind of numbers we're looking at. We have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. What comes next? Jack, and then queen, and then king. The ace could either be the 1, or sometimes it's the high card. It's higher than queen. It just depends on the situation. For today's purposes, we're going to assume ace is the low card. 13. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Are there any questions about cards? I'm sure you have kind of a general idea of what we're talking about. Sometimes it's confusing if you've never played cards before. I'm not familiar. So let's look at our first example. It says a card is being drawn from a standard deck. Find the probability of selecting a 7 or an 8. That keyword there is or. Find the probability of drawing a 7 or the probability of drawing an 8. Okay, so in a standard deck, how many cards are we looking at? 52. Of those 52 cards, how many 7s do we have? 4. There's 4 7s. We have a 7 of hearts, of diamonds, of clubs, of spades. We've got 4 7s. 4 tells us that we're going to add. Probability of drawing an 8. Of those 52 cards, how many are 8s? 4. There are also 4. We have hearts, diamonds, clubs, spades. We need to add these two fractions. When you add fractions, do you need a common denominator? Then we have one. So it's 8 out of 52. Which can be simplified using what? 2/13. You can use that math feature of your calculator that we talked about yesterday. Simplify for 2/13. Next example, a card is being drawn from a standard deck. Find the probability of neither club nor heart. Neither club nor heart. So they don't want a club, they don't want a heart. What do they want? Spades or diamonds. Probability of spades or diamonds. Alright, so how many spades are there? 13 out of 52 plus diamonds. How many are there? So we're adding these two fractions which already have a common denominator. 26 out of 52. And 26 divided by 52 is? 120. The French Club has 16 seniors, 12 juniors, 15 sophomores, and 21 freshmen as members. What is the probability that a member chosen at random is a junior or a senior? So we're going to find the probability of being a junior plus the probability of being a senior. How did I know I was going to add those probabilities? 4. 4 is kind of our keyword. It tells us that we're looking at mutually exclusive or possibly not mutually exclusive events. So probability of being a junior. How many juniors do they have? 4. Out of how many total students? 64. Plus the probability of being a senior. How many seniors are there? 16 out of 64. So let's go ahead and add 16 plus 12. 28 out of 64. 28 64s, it's simplified to 760. Next example says the French Club has 16 seniors, 12 juniors, 15 sophomores, and 21 freshmen as members, just like the last problem. What is the probability that a member chosen at random is not a senior? So if they're not a senior, what are we looking at?
Junior, sophomore, freshman.
Yeah, probability of being a junior plus the probability of being a sophomore plus the probability of being a freshman. How many juniors are there? Out of 12 out of 64. Plus sophomores
15,
out of
64,
plus freshmen
21,
out of
64.
64. So 12 plus 15 plus 21 is 48. Right, 48 out of 64, which can be simplified to 3/4. Now let me ask you, is there another way we could have done this, maybe without doing all this addition? I mean, instead of doing these 3 separate probabilities, is there another way we could have thought of it?
Add all the ones that weren't seniors.
Yeah, you could have, without actually writing out each of these probabilities, you could have thought, okay, not a senior, that means I have freshmen, sophomores, and juniors. Add up how many total students there are there, out of 64. And we essentially did that here. You may have been able to do a little bit of this. Alright, the next thing we're going to look at is not mutually exclusive. Not mutually exclusive. And again, we typically see that word or. That tells us either mutually exclusive or not mutually exclusive. So in this case, we'll find the probability of A plus the probability of B minus the probability of A and B. Not mutually exclusive events. Actually, I don't even want to tell you. I want you guys to kind of find this out when we look at the first example. I'm not going to tell you what it is. Okay, have a copy down? Oh, sorry. Okay. In the game of bingo, balls or tiles are numbered 1 through 75. These numbers correspond to columns on a bingo card, as shown in the table. A number is selected at random. What is the probability that it is a multiple of 5 or is in the in column? There's not a table there, but we can go ahead and make a table. You guys all played bingo before? In the game of bingo, there's certain numbers that are in the B column, certain numbers in the I column, etc. In the B column, they have the numbers 1 through 15. In the I column, the numbers 16 through 30. In column, 31 through 45. In the G column, 46 through 60. And the O column, 61 through 75. Huh? It was on my table. I didn't just randomly know that information. It was on my table. I just didn't have that table on your note sheet. You probably need this information. So it says, what is the probability that a number is a multiple of 5 or in the in column? What do I mean by multiple of 5?
Like
5, 10, 15, 20, 25, etc. Let's look at the B column. In the B column, how many multiples of 5 do we have? 3. What numbers?
5, 10, 15.
5, 10, and 15. There's 3 there. In the I column, how many do we have? 3 also. 20, 25, and 30. How about the N column? 3. We have 35, 40, and 45. G? 3. We have 50, 55, and 60. And O? 3 also. 65, 70, and 75. Alright. So the probability that a number that's selected is a multiple of 5. How many multiples of 5 do we have of 75 numbers? 15. 3 plus 3 plus 3 plus 3 plus 3, or 3 times 5 is 15. Out of how many total numbers?
35.
Plus, we want the probability that is in the in column. How many numbers do we have in the in column?
15.
There's 15 numbers in the in column. 31 to 45 out of 75 total numbers. Okay. Why can't I at this point just add 15 plus 15 and say it's 30 out of 75, simplify my answer?
Mutually exclusive.
Correct. So what do we need?
Find your,
What do we need to subtract?
Probability of A times probability of B.
Why? Why do we need to subtract? Jordan?
because one's independent of the other, so.
Not really dependent on one time. What do we need to subtract? Huh? The equation tells us to. You're right, it does. Not a wrong answer for sure. Why in this case do I need to subtract? Or what do I need to subtract? Does anybody know that? 10?
The probability of both happening would be 3 out of 75.
Yes. Why, Tim?
Because you have 3 numbers that are multiple of 5 in the end column.
There's 3 numbers that we've counted twice. In this first probability, this was the probability of being a multiple of 5, right? Right. So that first probability is the probability of being a multiple of 5. What was the second probability?
Being in column.
Being in the end column. We counted all our multiples of 5s. Right here. Aren't there 3 numbers that are multiples of 5 in the end column?
Yeah.
Okay, I counted them here. Aren't those 3 numbers also included in the 15 total numbers of the end column?
Yes.
I counted them there also. So I've got to subtract out those 3 numbers that I counted twice. Are you with me?
No.
Let's say this again. We first found the probability of being a multiple of 5. Those are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, etc. In this end column, what numbers do I have that were multiples of 5? 35, 40, and 45. Okay? I included those 3 numbers, 35, 40, 45, and also included 5, 10, and 15. I included 20, 25, and 30. Were you okay with where I got this first probability? 15 out of 75? Okay. For the second probability, that was all the total numbers in the end column. Well, what numbers do I have in the end column? 31 to 45, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. There are 15 of those numbers, right? Now, there are 3 numbers that I counted twice. 35, 40, and 45. You see that? These 3 numbers I counted when I did my multiples of 5. I also included those 3 numbers when I did numbers in the end column. We can't count them twice because that would just skew off our probability here. So we need to subtract out those 3 numbers that we counted twice. Does that make a little more sense? Jordan?
So could you just know that you were going to count them twice and not count them in the first place?
Yeah. You could have counted them here maybe, and then not counted them here. Yeah, it would be the same thing. Yeah, you could think of it that way. So let's go ahead and complete our probability. 15 plus 15 minus 3 is 27 out of 75. Use your math feature in your calculator. What does that simplify to? 920 plus. Let's look at another example where we've got a not mutually exclusive we're going to subtract out. Let's be our last example. In Mrs. Klein's class, 7 boys have brown eyes and 5 boys have blue eyes. Out of the girls, 6 have brown eyes and 8 have blue eyes. If a student is chosen at random from the class, what is the probability that the student will be a boy or have brown eyes? So we want to find the probability that we are going to select a boy or a student with brown eyes. So let's first find the probability of being a boy. How many total students do we have? 14, 26. Of those 26 students, how many are boys? 12. 7 with brown eyes, 5 with blue eyes, so 12. 4 means add. Here, the second one, we want to know the probability of selecting a student with brown eyes. Not necessarily a boy, but a student, boy or girl, with brown eyes. How many students total do we have? 26. Of those 26 students, how many have brown eyes? 7 plus 7 boys and 6 girls, 13. Now, I believe there's some kids that we counted twice, right? We counted the boys with brown eyes twice. We counted the boys here. And the second probability, we counted the boys and girls with brown eyes. Okay, so we have to subtract out those boys with brown eyes. How many do we have? 7. So minus 7 out of 26. 12 plus 13 is 25, and 25 minus 7. 18? Right, 18 out of 26. And 18 out of 26 simplifies to 9 thirteenths. Alright, so what is the keyword that we're looking for today when we're looking at mutually exclusive or not mutually exclusive? Or that tells us to use these formulas. I think I told you yesterday on your EOC you guys will have a formula sheet, and I think I'm pretty certain the probability formulas are on there. So you'll have access to those. Test the quiz, I will give you those formulas as well. Let's see. On independent and dependent, what we did yesterday, what was the keyword that we typically look for there? And. Alright, for today, I'm going to ask that you finish the packet from last night. I know you guys don't have that because I collected it from you to put it in the grade book. I'm going to go ahead and enter in the grade book right now. I'm going to enter it in the grade book right now. As I enter it, I'm going to call you up to get it and get started on